Hi, and welcome to today's webinar, How to Easily and Securely Connect Devices to AWS IoT. My name is Wally Oladahin. I'm a Senior Solutions Architect focused on AWS IoT. And we had the pleasure of having Mark Buster from Leviton, the Director of Cloud Services, to also talk about their journey using AWS IoT. So what will you learn today? The first thing we're going to cover is go into how to use AWS IoT Core, all the components of AWS IoT Core, and then we're going to dive into device management and AWS IoT Device Defender. We'll then dive into some use cases and some solutions, how you can start using these services together to build your IoT applications. And then we also have the pleasure of hearing about Leviton's use case, how they start using AWS IoT Core, and how it helps them solve their technical and business challenges. So what are customers doing today with AWS IoT? There's a wide range of use cases in the IoT verticals that customers are using AWS for. Whether it's predictive maintenance, being able to check if a gear or a part's about to fail, and then be able to proactively ship new parts to a given facility, or using it to maintain their device fleet, to be able to roll out updates, implement patches, and even do rollbacks of applications if they need to. Then there's a whole plethora range of other AWS solutions that people are using to build their IoT applications, whether it's in connected buildings or remote patient monitoring or in payments or retail. But for us in AWS, it really all starts with AWS IoT Core. AWS IoT Core is a managed service that lets customers securely and easily connect their devices to the cloud and other applications. AWS IoT Core is made up of several different components, from identity service, device gateway, our message broker, the rules engine, device shadow, and the registry. In each of the next sections, we'll give an overview of each of these components, and then we'll dive into the other parts of the AWS IoT ecosystem. First, we start with the identity service. The identity service is all about how do we identify devices out in the field. Devices, of course, can't have Facebook pages or LinkedIn logins. So what we do instead is we use X509 certificates that can either be generated by AWS IoT or they can be generated by a customer in their own PKI or HSM infrastructure. With these identity services and your X509 certificates, customers can then create fine-grained policies to restrict what a device can do, whether it can send a message into AWS IoT or whether it should be able to receive a message from AWS IoT Core. We then have the device gateway that really sits behind the identity service. Think about the device gateway as a long-lived bidirectional communication channel that runs over TCP. Devices can publish and subscribe to messages using multiple protocols. They can use MQTT over TCP/IP. You can do MQTT over WebSockets or using a RESTful HTTP interface. Tying into the identity service, what devices will use is X509 certificates to identify and authorize themselves. But if you have external applications or external users, they can also use SIG-v4 signing using AWS IAM credentials, or we even have released token-based authentication using your own custom authorizer. So if you use OAuth internally or another mechanism to authorize and identify users, you can use that at the device gateway. And all of this security and this communication happens over TLS 1.2. So just to walk through how the TLS works in AWS IoT Core, let's imagine you're going to just a regular website like you're going to Amazon.com. When you make a request to Amazon.com, of course, you would log in and you provide your credentials, but you also want to validate that you're talking to a server that is actually running an application from Amazon.com. So what would happen is on the server side, there's going to be some certificate that identifies Amazon.com that can be shared with other users or you as a user going through the browser. Amazon.com will also have its own private key. This is what's going to be used to encrypt the data that stays local to the server and is not shared with the external user. When you go to this site, you're able to check the certificate for the server, and then also through the encryption mechanism, ensure that you're talking just to Amazon.com. But again, as we mentioned, devices really don't have login credentials. So how do we do the same TLS using AWS IoT Core? We have our AWS IoT device gateway, our broker. During this TLS process, you initiate a TLS handshake. AWS IoT Core has the same mechanism. It will have a server certificate and associated private key. And you'll use this private key and certificate to basically ensure that you're only talking to AWS IoT Core. Based on the identity service we talked about earlier, there will be a private key and a certificate on each device. This private key is used to encrypt the traffic over this TLS communication, and a certificate is a way to identify that this is actually an IoT device that you deem as being valid. And this is how we achieve the same TLS communication using devices in AWS IoT Core. So now that we can identify ourselves, how does the identity and the gateway tie into permissions? In AWS IoT Core, you can control whether a device can connect to the AWS IoT service, can publish a message, subscribe to a given topic for communication, or receive a message. This is all linked by an AWS IoT policy that you then attach to your certificate. To give an example of an AWS IoT policy, we have two actions allowed on the screen. The first one is to allow an IoT publish on a topic called private topic using the device's client ID. The next one shows a subscribe example, where we want a device to subscribe on its own private topic, also using that device's client ID. So now that we've gone through identity access and inside of the device gateway, the next part of AWS IoT Core is the message broker. This is a scalable, low latent, reliable MQTT protocol where your devices, again, will publish and subscribe to other devices and applications. This message broker really allows you to decouple this communication. So if a device is on or offline, you can either have it published to AWS IoT message broker, then have it routed to other internal services or down to the devices. And because this follows the MQTT 311 specification, you really get to customize your topic space structure. So you can support wildcards, you can support pounds and plus signs, all the capabilities of MQTT in terms of the pub-sub model of communication. To give an example of what publishing and subscribing will look like, on the far left, we have a number of devices, and each device has its own client ID. So the device on the top left has device AAA, device BBB, CCC, and DDD. Each one of these devices are going to publish to its own topic. As the devices are publishing to a topic, on the far right, we have one device that's subscribing, and that subscription is using a single level wildcard topic structure, which is a plus sign. So as any of these devices on the left publish their message inbound, it goes to the AWS IoT Core MQTT broker, and then this gets routed down to the device that is subscribing on this topic channel. The next part of AWS IoT Core is the device shadow. This is really your virtual representation of your device in the cloud. You can think of the shadow as a way of doing command and control, where you can give your devices a specific setting, and then the AWS IoT shadow will store that information and then send out a message to the downstream device. Even if your device is offline, you're able to use the AWS IoT device shadow to retrieve the last known state of the device. You're also able to use RESTful APIs to retrieve the device information from the shadow through other applications. To give an idea of how the AWS IoT Core device shadow is laid out, we have three different entities. We have our device, which is going to report its current state. We have our shadow. Our shadow is that virtual representation of that state in the cloud, and it's made up of a desired, reported, and a delta state. And we have our application. This is really an external application that has the ability to send down a command to the device or receive updates from the device. The shadow format uses JSON. So if you look at the right of our screen, we have all of those individual states, desired, reported, and delta, all represented as JSON. Our devices will update the reported state. The shadow will be updated via the desired states. And then whatever is the difference between the two is automatically added to the delta. In addition to these fields, we also allow you to have a version number that's automatically incremented every time a shadow is updated. This allows your applications to do things like version locking to make sure that if you decide to do an update, that your device has the latest version of the shadow. We also include a timestamp of the last time the device has updated the shadow or a user has updated the shadow, and a client token, which really is a session token. It allows you to set a token inside of this field that is then sent down when this message is updated or when this message is received down from a device. So to show this end-to-end shadow workflow, we'll have our device again on the left. In the middle is the AWS IoT Core device shadow, and on the right is our application. Our device is going to publish its current state to AWS IoT Core. This JSON document is then persisted in the AWS IoT Core device shadow service. Our application can then retrieve the current state and then can issue another request to change the state. This also goes down to AWS IoT Core device shadow and gets persisted again. Our device can subscribe to these changes and actually receive an update that a request has been made. Let's say it wants to turn down its wind speed from 55 miles per hour to 35 miles per hour. Our windmill can take this change, issue it locally, and once it's complete, it can actually publish its new current state back to AWS IoT Core, and it gets stored in the device shadow again. And now our third-party application can just be listening in to know that this shadow change has been confirmed. And this is the end-to-end workflow for the AWS IoT Core device shadow. The next part of AWS IoT Core is the registry. You can think of the registry as a way of storing immutable data about your device. This is things like the serial number or the manufacturing ID, really things that don't really change once a device has been provisioned. In the registry, you can also have thing types, which is really similar to a class of an object. You can have a light bulb or a car or an electric car that represents which attributes should be known on this device or set at all times. You can also use the registry as a way to create thing groups, which I'll talk about a little bit later when I get to AWS IoT device management. The last part of AWS IoT Core is the rules engine. The rules engine allows you to take a message and then route it to other AWS IoT services. You can route it to AWS services like Kinesis or SNS or SQS. You can also do things like republish a message to another AWS IoT topic. The rules engine supports a SQL-like syntax that allows you to identify when a message is important and needs to be sent to another service. Just to break down the syntax of a rules engine rule, we have the following attributes. On the very top, we have our SQL-like statement, where we will select some information from the payload and some information from a specific topic. Then we specify all our actions. In this case, we're going to route a message to S3 and put it in a particular bucket, or we're going to republish a message. For every single action, we associate an IAM role. This allows AWS IoT to assume a role to then talk to the upstream service. So in the first case, we assume a role to talk to S3, and in the second case, we assume a role to republish. To break this down a little further, let's look at our topics on the left, the rules that we've configured in AWS IoT Core in the middle, and what actions they'll trigger on the right. If we were to publish a message to PWS/station1, temperature or wind, it would match the first rule, which would then push that message to S3. Let's say we publish to station 1 or station 2. This would match to our second rule because we're listing on select star from PWS/pound, which means match anything else after PWS. So these would all go to Amazon Elasticsearch Service. In our last example, let's say we want to match anything that's temperature inside of any given station. In this case, this would trigger our third rule, where we'll select star from PWS / single level wildcard, which is our plus / temperature. Now that we've covered the AWS IoT Core and other services like AWS IoT Shadow and the rules engine that are part of Core, I'd like to introduce Mark Buster to talk about Leviton and their use case using AWS IoT Core. Mark, I'll hand the floor over to you.
Thanks, Wally. I'm really excited to be participating in this webinar today. I've been a longtime viewer of AWS webinars, so it's exciting for me to be able to actually participate in this one. Again, like he said, my name is Mark Buster. I'm the Director of Cloud Services for Leviton, and I just want to share a little bit about our company. One of the interesting notes that you'll see on this slide is that 65% of the homes in the US actually contain one or more devices that we manufacture. Most of you probably have never heard of us, or you don't recognize the devices that we may have manufactured that are present in your home, but it'd be things like wall switches, receptacles, the GFCIs that you may have in your bathroom or in your kitchen, all those types of things. And we're also a pretty large company, pretty old company, over 110 years old, 25,000 different products that we manufacture, and those span all kinds of different industries. There's commercial spaces and industrial spaces. Today we're going to be talking about some of the residential spaces that we work on, or that we have products in, and we actually have products available in over 100 countries as well. So the case study that I want to present today is about our Decora Smart Wi-Fi connected devices, which are composed of the switches, or in-wall switches, dimmers, and also some plug-in devices, one of which is a dimmer and the other is an outlet, which is essentially switching but does not dim. So the dimmer module would be good for plugging in a lamp, whereas the plug-in module or the outlet module would be more like for something like a fan or a pump or something that you wouldn't want to be dimming. So dimmers for lights, outlets for sort of motor control types of things, and then we have the three different options for your in-wall. This is a really interesting case study for AWS IoT because this is really Leviton's first direct-to-consumer smart home sort of play, where we are, we've got what we call our My Leviton home services and an associated mobile app, and then all these connected devices. And one of the key components is also voice control and activation, which was one of the things that got us involved in this project in the first place through Amazon Echo, or the Alexa service, which I'm sure everyone watching this webinar is familiar with. So this suite of products is really sort of represents a next generation of where Leviton as a company, or at least this product grouping, is moving forward. And obviously there are use cases for industrial, commercial, and many of the other things that Wally already touched on, but this particular product is a great example of what we're already doing today with the AWS IoT service. So for Decora Smart with Wi-Fi, it's, to the user, it's Wi-Fi switches or devices and a mobile app. Now, when we designed the system, we realized that we needed local and remote control. So obviously it's an in-wall switch. You need local control to be able to walk up and control the thing, just like any other light switch. And you also want to be able to control things remotely, from whether remote means on your couch or whether remote means out in the world somewhere. And you want to trigger an activity like turning on all your lights, or turning on your outside lights, or turning something off because you forgot to turn off, your kitchen lights, or who knows what. So we have a mobile app that allows you to create schedules for all these things, these activities, and really customize it for how you want your smart home system to work. one of the other important things about this is that we wanted them to be truly smart. So we want the schedules and things like that to be able to continue to work whether cloud connectivity goes away. In other words, if you've got lighting schedules set up and your internet goes out, you don't want your lighting schedules to not work. So it's important for us to have sort of distributed intelligence between the devices and the cloud. And I'm referencing all this stuff because it's leading up towards how we ended up at IoT. So what all these products and all these plans and apps and all these things really come together as a platform for us to continue to expand on with new products that we're going to continue to leverage the IoT platform and building out this cloud infrastructure and our mobile app infrastructure to continue to add more devices and more connectivity so that we can create a really exciting and powerful smart home offering. So why did we choose AWS IoT? Really, it was looking back, it was a no-brainer. But of course, we did our due diligence. The requirements for the Decora Smart project. When we first started researching this idea or this set of ideas, we really were excited about voice, and everyone's really excited about voice these days. When I say voice, I'm talking about Alexa. I'm talking about Amazon Echo and all the different Echo products that are out there because it just makes so much sense from a smart home perspective to have voice control. So we knew we had to have that. That was one of the main driving factors. We also wanted it to be hubless. So we wanted the devices, the individual devices, to be able to talk up to our cloud service without relying on a centralized hub like some of our competitors do. I won't name names. But it was really important for us to have a hubless architecture, but still maintain that local intelligence like I was talking about with the scheduling and things that are built into the switches themselves. So that was super important for us. And other things that made a huge difference for us was a requirement for fast prototyping, because even though I mentioned earlier that we are a very large corporation split across multiple business units, there's huge engineering teams. This particular product line was actually developed in the USA by myself and a small group. I say a small team, and that means different things to everyone. But if I actually reveal the number of just how small the team was that put this together and how fast we were able to do it using these tools, I think you'd be amazed. So the next important thing for us was standards compliance. We needed to be able to rely on something that essentially wasn't homegrown, that was well vetted by across multiple industries and supported by a large sort of development group or effort, and something that's, like I said, well vetted and something we can count on moving towards the future. And MQTT is a well-defined structure and standard, as well I mentioned, that provides sort of all of these different bits and pieces of this communication protocol that's perfect for this particular application. So that one made a lot of sense for us. And in terms of security, again, using the standards of the certificates, also the possibility to use IAM rules and all the different options that they have made it very attractive to us. And it's a managed service. So for us, if you're managing a massive fleet of these devices, whether they're light switches or cars or tractors or windmills or whatever they are, actually managing that is a huge task. So for us, we knew that we wanted to be able to offload that, and already working with AWS, of course, we did our due diligence and we looked at some other vendors, but what we came back to was these guys are doing it better. We've got a great relationship with AWS already, and this was the best offering for us, all these things considered. So when the dust settled, the obvious choice for us was AWS IoT Core. Actually, when we made that decision, it was already a great solution, but since that time, they've continued to add new functionality to it, which makes it even more exciting and more powerful. But we did arrive at that decision because A, we were already using AWS for a number of things and had great experiences with them. And I've had great support. And I say I mean we as a team have had great support from our solutions architect. Wale is a senior solutions architect, but I've worked with a number of the other ones. And I would just, as a side note, just make the recommendation to all you guys that are watching this webinar, if you're not talking to your solutions architect, you need to make that one of the next things that you do, because their job is not to sell you anything. Their job is to make sure you're getting the most out of the services that you're using and to suggest perhaps a better or more cost-effective way to get to where you're going. So leverage your solutions architects. I should have noted that in the slide, but I definitely did want to point that out in this presentation. But continue to move forward. So super fast development, in part enabled by talking with our solutions architects. And also we have a small team that actually functions as a benefit. And in some cases, because we're able to move fast, there's fewer levels of bureaucracy. And we knew that was super important if we wanted to be able to get this product line on the market as soon as possible and be able to leverage, the voice integration and all those things. And it also has tight integration with services. And when I say services, I'm talking about internal AWS services. So all the things that we're already using or might be using in the future, the IoT core and rules engine allows that super tight, seamless integration. And that's one of the other things that made us really excited about IoT core, the rules engine, and IoT in general. So the IoT rules engine, while I give a great explanation of how it works technically, and I'm going to give a little bit of an example of how we use it, it can do much more than what I'm going to explain right now. But this is what kind of a real world use case of how we use it. He already explained that it manages communication amongst services, or basically it's the way for incoming messages to be converted into actionable events. So we use it to control communication with our own, essentially, cloud service, which is what manages many other aspects of our application. And it also monitors and reacts to connectivity changes on the devices, which, so those are the two main jobs that we use the rules engine for. And I'll shortly show a diagram that sort of shows end-to-end how we use these different parts of IoT core, including the device shadow, the core, the rules engine, and from device all the way to the end user's smartphone or Echo, or however the actual control mechanism may happen to be. So here is a fairly high-level overview of how Decora Smart with Wi-Fi leverages the AWS IoT core and some other AWS services to accomplish our goals. So starting from the left, you see one of our in-wall switches or dimmers. And you can tell it looks just like pretty much any other in-wall dimmer, perhaps a little smarter. You see the little dim bar on the side there, but it does connect over Wi-Fi using our mobile app to commission the device, and it uses the IoT MQTT protocol, as well I mentioned, and it uses that to communicate essentially with the device shadow. Well, I already went into deeper detail how exactly that works, but in briefly, it handles that communication level for us, and the device shadow, the way I prefer to think of it, is a sort of a virtual representation of the physical device. By the same token, the physical device is sort of a physical rendering of the IoT shadow. So for us, all we have to do, and I say us as application developers, is manipulate the shadow and watch the shadow for changes. So if we want to control a light switch, all we have to do is set a property on that IoT shadow, and the AWS IoT engine it handles everything else for us. The IoT MQTT protocol allows that, and the communication channel that takes care of that. So all we have to do is manipulate a property. The property shows up at the switch, and the switch turns on or off or goes to a specific DIM level, etc. And it's instantaneous. It's outperformed kind of our wildest sort of expectations. To the end user, it literally appears to be instantaneous. So the other side of that is what happens when you go up and touch the wall switch and manually activate it, turn it on, turn it off, dim it to a level. Well, now a message comes up and hits the IoT shadow. So once that happens, we're now flowing up into the rules engine, and we have a series of rules to accomplish different tasks. But for this case, in this example, we sort of pipe that information into an Amazon or an AWS SQS queue, which is one of the message queuing services that's available through AWS. And we subscribe to the appropriate queue for the event that's happened. And that alerts our larger our larger MyLeviton cloud service, which will then take action depending on the type of message that was received. So if it's a device went offline, or if it's a device went online or changed in some way, a property got set, like got turned on, got turned off, was dimmed to a certain level manually, our service then is able to take that information and act upon it. So what kind of actions? Things like updating the mobile app in real time, or interacting with a Lambda function, which interacts with a Alexa smart home skill. So because like I said, we knew that we needed to be able to integrate with voice, and Alexa smart home skills, Lambda functions, that's how you do that. And having all these things together, all these building blocks, makes it really simple for us to just sort of tinker. It's kind of like Tinker Toys or Legos. You just plug all these building blocks together, and all of a sudden you got this massive scalable architecture that just, you hear the phrase "just works." It just works. It's been an outstanding experience for us. And working in the other direction, let's say you either are talking to your Alexa device or your mobile app, using it to control. It talks back to our MyLeviton service, which would in turn then talk back and write directly to the shadow, handing that off to the IoT core, which does the heavy lifting there of managing all those that massive fleet of devices that are out there, and sending the right command to the right device. And again, it's instantaneous and it's seamless. So for us, IoT Core was absolutely the right choice. We've adopted it and we haven't looked back. We will continue to use it. We're excited about a lot of the new features and functionality that has recently come out. I would say one of the most powerful features of it, or the two most powerful features of it, are the registry and the IoT shadow, because I just like that paradigm of the virtual representation that gets rendered on the physical device. It's so simple. There's no real like us talking directly to the device. We just write a property and let IoT do the work. The other one is the rules engine. There's all kinds of things you can do when an IoT event occurs through that rules engine. You can process them in so many different ways and filter out different events from groups of devices or individual devices, and pump that into whatever service you want to, whether it's your own service or an SQS queue, like I have diagrammed here, or any of the other things like, well, I mentioned pump information into an S3 bucket if you just want to keep some logging. And you can do all these things in parallel. You can do them individually. You can do them to split work across different platforms or services. So there's just a ton you can do with the rules engine. So again, I would stress, read up on all the documentation that's out there. There's a ton of it. Take advantage of webinars like these ones, and talk to your solutions architect, like I said before, because they will help you through these things. If you have any questions at all, that's what their job is. Like I said, it's not to sell you something. It's to make sure that you're doing the right things and getting the most bang for your buck, and not not making any mistakes as far as best practices are concerned. So this is, like I said, a fairly high level overview of a real world application that's out there on the market today and doing fantastic. We're thrilled with it. And we owe a lot of its success and our speed to market due to the power that the AWS IoT core and associated services were able to give to us. So hopefully that was illustrative and you got some information out of that. And with that, I'm going to hand it back to Wally. So thanks again to everyone for letting me chat at you for a while today, and take it away, Wally.
Thank you so much, Mark. It's great to hear customer use cases that are using AWS IoT and really seeing how customers are able to really focus on their core differentiators and let AWS really take care of that heavy lifting for you. So now that we've really covered a lot of AWS IoT core, I do want to jump into two other AWS services, AWS Device Management, and in a few slides, AWS Device Defender. With AWS IoT Device Management, the service really helps customers onboard, organize, and monitor their applications once they're deployed out to the field. You can do batch fleet provisioning, real-time search and index through a Lucene type cluster. You can implement fine-grained logging based on different groups of devices. And you can do over-the-air updates. So you can do patches on devices or roll out new firmware. So let's dive into each one of these features in a little bit more depth. With batch fleet provisioning, what we heard from customers is that they would go through this manufacturing process and they would want to deploy 100,000 devices that have been provisioned completely offline. And they had a manifest of all of this data that was already created based on this manufacturing process. And they wanted a really quick way to be able to get all of this device information into the device registry in AWS IoT Core. So what batch fleet provisioning does, it allows you to create a JSON-like template that lists all of this metadata about your device. The name of the device, the type that the device might be, information about the certificate or the default policy, IoT policy you want the device to have from a security perspective. And then via the console or the CLI, you can start a batch fleet processing provisioning job. And what this job will do is it will take this manifest file, this JSON file, and then pre-provision all of the devices directly in the device registry. And we found this was a great way for customers really to onboard devices in bulk instead of doing these one at a time through the console or the CLI. In device management, we also released a real-time fleet index. And what this does, it basically allows you to query the current state of your device from data that's in the device registry or in the AWS IoT shadow. I'll jump into a demo a little bit later, but inside of your settings in AWS IoT, you're able to turn on fleet indexing. And when this feature is turned on, all of these changes are replicated into an index that's managed by AWS IoT. Then you can submit all types of queries against that data. You could say, find all devices that are manufactured after a certain date. You can do things like find any devices that have a battery life greater than 50% based on information in the shadow. And again, this is completely managed for you. So just through a few clicks in the console, you can have this search-like experience on top of the registry and the shadow. In device management, we also added fine-grained device logging and monitoring. What you're able to do is turn on up and down the log levels based on an individual group of devices. Based on these log levels, these all are sent to CloudWatch logs, and you can take that information to help you troubleshoot devices, diagnose what's happening with devices, or just get additional detail based on the logs that are produced. And the last part of device management is over-the-air updates. With over-the-air updates, you can push updates to devices that are deployed out into the field. With over-the-air updates, we've created a set of MQTT topics that notify a device when a job is ready, and a device can now publish to a specific job topic to illustrate where it is in its update process. With device management, you can target a group of devices to update, or you can pinpoint a single device. And you can control how quickly devices get rolled out, where you can specify per minute how many devices should receive this update. To dive into how these features all fit together with device management, let's go into a little bit more depth about thing groups. This is a part about organizing your devices through device management. With thing groups, you can create a hierarchy that describes a different subsets of your devices and their groups that they're in. So in this case, I can create a hierarchy of groups that start at a given location. Then for each location, I can specify whether you're in a floor, the basement, or it's a device that's located on the roof. And I can even have subgroups within other groups. So for example, for floor, I can specify different types of floors. Is it the guest room or the lobby? And I can continue this down and down with groups until I have my individual devices at the very, very bottom of my hierarchy. Once this is defined, you can start taking advantage of other AWS services as part of device management. For example, with the same hierarchy, you can create IoT policies. So you can say by default, any device that's in a given location should have a default policy that allows it to publish on a location topic. You can extend this policy down the hierarchical tree. So I could create another policy that says if you're in a guest room, you get additional permissions to publish to a guest room topic, and so on and so forth. We found that this allows customers to really control and manage their IoT policies at a group level, as opposed to doing it at an individual device level. In addition, within groups, you can take the concept of log levels even further with fine-grained logging. So once you have your devices out in the field, you might have an account level for your logging that's set to error. You only want to get error messages across the entire fleet of your devices. But let's say in addition, you want to be able to troubleshoot groups. So you can take this group concept and create a troubleshooting group, and then within that group, you can create subgroups. I'll have a monitoring group where the log level is set to warning. Then I'll have an error group where the log level is set to debug. And with the ability to add and remove devices from groups, I can take a device that's in production, and if I see that I want to get more information, I can move it to the error group, so it's set to debug. If I want to get a bit more detail, like I think there's warning errors, I can move that same device to the monitoring group where the log level is set to warning. So now you have fine-grained control using thing groups in addition to the logging and device management. So the other service I wanted to talk about is Device Defender. Device Defender is a fully managed IoT security service that really enables you to secure your fleet of devices that are connected to AWS IoT Core. You'll be able to audit your devices and the configurations related to them. You'll be able to detect when devices drift out of a preset set of requirements and permutations you expect. Then you can generate alerts. And if there is an issue, you can then use this notification to trigger a job using AWS IoT device management. So the subcomponents in Device Defender, we have the audit device configurations feature. You can monitor the device behavior. Then based on a preset list of attributes, you can identify anomalies, and then you'll be able to generate alerts or notifications. And that allows you as a customer to define what to do next with this notification. Again, as an example, you might decide to patch vulnerabilities, or you might push an SNS notification to an administrator or someone who's on call so they can dive in a bit further. Let's touch on all of these features in a bit more detail. With device configurations, you'll be able to audit against a pre-built list of IoT security best practices. You can then run those audits on a scheduled basis, either daily or weekly, or you can run them ad hoc based on a specific period. For example, you might want to run your audit ad hoc right after a firmware update to confirm that all of your settings have been applied correctly. Some examples of audits to spot security gaps could be to see if a device is using the same certificate across devices. As mentioned, that certificate is an identity for a particular device. So if it's used in multiple places, you want to be able to detect it. Or even expiring certificates. So you want an alert once a certificate is about to expire in 30 days or 90 days. You can also monitor device behavior. So what Device Defender will do is that your devices will be able to send incoming metrics about the connectivity and information about that device. You're then able to create your own device profile to say, what is my expected behavior from the device, such as should it always come from a given IP, or how it should actually communicate to AWS IoT Core. Then you'll be able to do a baseline between what you're currently seeing from a given device and what you expect to be seeing based on this device profile. And based on that information, as you monitor, you can then decide again, is a device in or out of range of what is expected behavior? Based on that information, you can start identifying anomalies. You can blacklist or whitelist behaviors, so you can check if ports are open based on the metadata that's being sent from this device that shouldn't be open. You can also check different thresholds. So does the device have more active connections than you're expecting? Is it listing on multiple ports that it shouldn't be listening on, or have them open? Is it sending more packets outbound than you're actually anticipating in that same 24-hour period? You'll also be able to do things like check for authorization failures. So is it unable to connect to the cloud because its certificate is invalid or for some other reason? Based on those anomalies, you can then generate alerts. Alerts can be sent to the AWS IoT console, so you'll be able to view the alerts directly in the console. You'll also get this information in Amazon CloudWatch. And as mentioned, you can push it to Amazon SNS. And from there, you can alert external users, such as your administrators or someone who has your security runbook that's ready to troubleshoot. You'll also be able to review the historical and contextual information about your fleet when it fails an audit. And the last step, once you have this notification, is really to be able to take action. So now you can go ahead and start patching security vulnerabilities. Maybe that means you're revoking certificates or removing permissions, or you're pushing out a firmware update so that you can essentially patch a security issue that might have existed with the previous version. So we've covered AWS IoT Core, AWS IoT Device Management, and AWS IoT Device Defender. To help you kind of visualize all the components of AWS IoT that we've covered so far, I'm going to jump into a demo and actually show you how quickly and easy it is to really get up and running using all of these services together. So to start, what I have running is a CloudFormation stack. In this CloudFormation stack, the general purpose of it is just to be able to launch part of AWS IoT Core inside of my account. So to show you what's actually running, it's a simple CloudFormation template where I have AWS IoT serverless as the CloudFormation transform that I'm using. I have a rule name just to give my IoT rule and identity. And then the SQL-like syntax is going to be what is going to identify a message that I want to listen to and trigger a rule. And the rule I'm going to trigger is a Lambda function. So my Lambda function is going to fire whenever a firmware update in IoT job and device management is triggered. To show you what this rule looks like, I have my rule currently enabled from CloudFormation. There's my topic that I'm listening to for a job being successful. And AWS IoT Device Management will send this on completion of a job. And this is going to trigger my Lambda function. Just to show you what my Lambda function looks like, its role is going to be to take a job, a device, once it finishes an update, and then move it to another group that needs to be configured for patching. So we're really doing this continuous deployment. So if my device were to be unboxed for the first time and it's been on the shelf for a year, it'll be added to a default group. It'll apply the first level of patching, and then it gets moved into another group. And in order to facilitate that device moving, just have my Lambda function with a little bit of logic in it. My Lambda function will find the default group. In this case, I'll use firmware 1. It's hard-coded, but in production, you could easily pull this from an external data store like Dynamo. We'll then remove it, once it's applied as update, it's no longer in the base firmware group. It's ready to go to the next group. So we remove it from that group. And then what we do is we'll actually add the device, to the next group. So again, it's almost like a continuous deployment. We're trying to take it through the base stage. This device has been on the shelf for a year to current state. So we're going to roll it through all of these groups. So we take the firmware patch group and now we add the device to it. And just to show, we don't really have a group configured yet, but we're going to add this in a little bit. And if you wanted to actually spin up a device, I'm going to be using just the configure a device underneath the onboarding. So we actually have a few levels of examples for device management, and this is one you can get from the configuring devices. So what I'll do now is I'm going to go into my terminal. I'm going to start running this device. So it's going to come up, it's going to be listening to notifications on this job document structure. My first step, so I don't mess up my command lines too much, I'm going to create my first group. So this firmware patch is going to be the initial onboarding group. This is when a device first comes up and it says, I'm out of date, which group should I go to? So that's our firmware 1 group. And I'm going to create another group. This group is going to be where my device moves to once it's actually applied its update. Now, just to show what this looks like in the console, we'll go to Groups. I'll refresh my screen. And now we have both of our groups here. And inside of my group, I can look at things, and as you can see, there's nothing inside of things 1. So let's imagine that what ends up happening is our customer unboxes their device, they have it connected, and now we notice that this device is brand new. So what will happen is that we will add this device automatically to firmware 1. If we go into our console again, we'll just refresh. We'll click on things, and it's in firmware 1 as we expect it to be. But in order to start migrating all of these devices, I can do this one at a time. I want to be able to get them as quickly as possible to apply their update and get themselves into the next group. So what I'm going to do is I'm going to actually create an AWS IoT job. And I'll walk through this syntax just a little bit so we can read it in together. So I'm calling create job. I'm giving it a job ID. This is a unique identifier for this job. So IoT webinar getting started demo. And my target, the deployment for this job, is going to be the firmware group 1. I'm going to give it a document called sample.job.json and a description, continuous job to update firmware from V1 to patch 1. And for now, I'm going to make this target a snapshot. I want this job to happen once. If I wanted this job to continue to run as new devices get added, I would change target selection to continuous. But for this demo, we'll keep it at snapshot just so we can see it move over the first time. So now I've run my job. If I go to the other tab, you'll see how quick this was. What ends up happening is my device gets notified immediately that it has a job waiting for it. It prints out that I have a custom job and what the job ID is, IoT webinar getting started demo. And as soon as it receives it, it pulls down a JSON file from S3, applies a change, which is just printing out this statement, and then triggers to the job service that it's complete. Now, based on the Lambda function, when this completes, what should happen is my device should move to firmware patch group. So as you can see, I could go inside of firmware patch, and now here's my thing. If I go into my Lambda function to see the logs as well, You'll see my Lambda function was invoked once when the job was complete. And you'll see that my device, once it's finished its update, it's published a job execution event with a succeeded and a job ID, and there's my thing. So as you can see, with just CloudFormation, a little bit of Lambda and the rules engine, I'm able to actually start rolling out updates to devices and then being able to trigger my own upstream actions once a firmware update has been taken. And this all uses AWS IoT Core and device management. So just to show this end-to-end architecture, I have me, the user, on the far right. I pushed a job to AWS IoT Core, and that job references an object in S3. My device is subscribed to a topic called thing name, jobs notify next, so it gets the next job it needs to do. It then publishes on a update when it actually completes the job. And this notification triggers an IoT rule that triggers my Lambda function. So just with a few services, I'm able to really start leveraging AWS IoT Core and other services like AWS IoT Device Management. So in summary, we've really covered a lot of ground today. We talked about how AWS IoT Core can help you easily and securely connect devices using services like the device gateway, the MQTT broker, shadows, and the rules engine. Then we dove into how AWS IoT Device Management and Device Defender can support and ease your day-to-day operations in IoT. Then we had the pleasure of having Leviton and Mark Buster speak about how they're using AWS IoT Core to really help them solve their IoT challenges. So thank you so much for joining this webinar today. Look forward to your questions. Thank you again.